All right, welcome to topic number 24, rational function and their graphs. So in this particular topic, I'm going to show you how to graph rational functions by hand. Okay. So a lot of times when we graph in the graphing calculator, um, we actually, there are things actually, actually we don't see, especially a whole inner function, vertical asymptote, and horizontal asymptote. So by teaching you how to graph it by hand, we actually going to establish where the asymptotes are located first. Then we're going to learn how to find few points that will actually help us graph the function a little bit more accurately. All right, so I'm gonna go ahead and get started, and and I'll also refresh your memory on the asymptote here in a minute. So I'm gonna actually copy this just in case if I get too far. All right, solve for x. So I'm gonna find some x-intercept first. Okay, that I'm gonna establish some points. So solve for x to find the x-intercept, and you want to make sure you write the answer as an ordered pair. So x-intercept means find x when the y is equal to 0. So my f of x is the y, so that will be 0 equals 4x plus 2 over x squared plus 4x minus 5. So I'm going to use cross product. It's probably one of the easiest way to do it. So 0 times all these three terms down here is 0. 1 times those two terms is still 4x plus 2. All right, so right now I actually have a linear equation. So move the 2 over. That give me 4x equal to negative 2. Divide both sides by 4. X equal to negative 2 over 4, which is a negative half. So my x-intercept is at negative half or negative 0.5 comma 0. All right. Find the y-intercept. Find y-intercept means find y when all the x's are 0. So if I substitute 0 for all the x's, and here, I'm gonna have a, I want to make sure I have a fraction answers. 4 times 0 plus 2 over 0 squared plus 4 times 0 minus 5. So all these terms all going to become 0. I only end up with positive 2 over negative 5, which is negative 2 over 5. So the y-intercept, 0 comma negative 2 over 5. Okay, it's very small. This is about negative 0.4. So it's right below the x-axis. Well, right below the origin, I mean. All right, factor the rational function. So if you take a look at the function, 4x plus 2, I can factor out a 2. So the reason why I'm asking to factor the function is because I'm in the process to find the vertical asymptote. If I factor out a 2, that'll give me 2x plus 1. I want to see if I have a hole in the function. So I want to factor and then see if anything can be canceled out. If I factor the denominator, x and x, or 1 and 1, for 5, use 1 and 5. My outer is 5, my inner is 1. So to end up with a positive 4 in the middle, I need positive 5 and negative 1. Since my last sign is negative, I know my signs in the parenthesis, one positive, one will be negative. So by looking at this, I know I don't have anything to cancel out. So reduce any common factor between numerator if there is any. So there's no common factors. Okay, one of the steps on how to find the vertical asymptote is factor your functions, reduce, see if you got any common factor where you can reduce, and then set the remaining denominator equal to 0 and solve for x. So x minus 1 equal to 0. So x got to equal to 1. The other vertical asymptote, move the positive 5 over, the other vertical asymptote, x equal to -5. So I got two vertical asymptotes. All right. So now already my function has, my graph has already been divided into 3 parts already. All right, looking back at the original function, identify the horizontal asymptote. So remember, the asymptotes, there are 3 scenarios, okay? So right now my degree of the numerator is 1. The degree of the denominator is 2. So when the degree of the numerator is less than the denominator, then the x-axis or y equal to 0 will be your horizontal asymptote. All right, up here, those are the vertical asymptotes. So I got my asymptotes. Okay, I got two x-intercept. I mean, I got one x-intercept, one y-intercept. So let's find some. Let's find some more points. Okay, because right now I know I got two vertical asymptote, right? So I'm going to find. Let me go back up a little bit. All right, 1 and -5. The x equal to 1 got to be on the right hand side. All right, so I know I got two vertical asymptotes. So now I want to pick an x value to the left of the vertical asymptote. Okay, to the left of the most left vertical asymptote, other than the x-intercept, and find its y value. Pick an x value to the left of the leftmost vertical asymptote. Okay, find its y value, but don't repick the same x and the same x-intercept. So this is x equal to -5. So I'm just going to pick x equal to -6. How about that? So if I substitute -6 back into my function, all right, let's see what the top is, okay? So 4 times -6 plus 2, -22. What we are focusing on here is not so much what the answer is, it's what the sign is. Positive or negative y value. Now, -6 whole into square is positive 36 minus 12 minus 5. I can do this real quick. That's 19, right? So my y value, okay, so this point is -6, -22 over 19. Okay, -22 over 19 is about -1 point something. Okay, so it's not so much of that 1 point something, it's so much about the signs. Because that tell me that it's trying to tell me that when x equal to -6, my function will actually go below, will actually stay below the x-axis. Because remember, y equal to 0 was my horizontal asymptote, or the x-axis. So in a minute, when I graph it, I know when x equal to -6, the y value is negative. So that means that part of the function stays below your horizontal asymptote or the x-axis. All right, pick an x value that is between the vertical asymptotes. Okay, I'm gonna pick an x value that's between your two vertical asymptotes. So I'm not gonna pick x equal to 0 because that will give me back the y-intercept. So how about just -1? Okay, or -2, don't matter. Tell you what, let's do -2. So if I pick x to be -2, substitute back into the function. All right, this is -8 plus 2. -8 plus 2 is -6 over. This is 4 This is -4 minus 5. So there's 0 minus 5, which is -5, which is positive 6 over 5. So -2, 6 over 5. 6 over 5 is about 1 point something again. All right. So, but this is positive. So that tell me that, hey, when I pick x to be -2, my function is actually above. Okay. My function is actually above the x-axis. All right. Pick an x value that is to the right of the rightmost vertical asymptote. So the rightmost vertical asymptote is x equal to 1. So I'm just going to pick 2. X equal to positive 2. All right, that's 4 times 2 plus 2 over 2 squared plus 2 times -2 minus 5. So that's 8 plus 2 is 10 over. This is 4 minus 4 minus 5. So that will be -5. So 10 over -5 is -2. So when x equal to 2, my y value is -2. All right. So far we have these 3 points we just found. Okay. Plus the x-intercept, y-intercept. All right. Let's see. Number 10. Let's see if, mathematically speaking, will the function, will the graph cross over the horizontal asymptote or not? So think about it. Okay. I want you to think real hard on this. Right now, this is my function. Horizontal asymptote. Your horizontal asymptote is y equal to 0, which is the same as the x-axis, right? And we already found the x-intercept earlier to be -0.5 comma 0. So if you put all this together, will my function cross over the horizontal asymptote, which is the x-axis? The answer will be yes. Where at? Well, so far I know it's at -0.5 comma 0, because to demonstrate mathematically whether the function will cross over the horizontal asymptote or not, we have to set the function equal to the horizontal asymptote, which is y equal to 0. But so I already did all this earlier. Remember, we did a cross product in number 1. We already said that 4x plus 2 is going to equal to 0, right? So x is going to be -0.5. So that means the function will cross horizontal asymptote or the x-axis at x equal to -0.5. That's the only point it will actually cross it at. Okay, very important that you understand that, it only crosses at one particular point, nowhere else. All right, for number 11, plot your x-intercept, y-intercept, draw the vertical asymptote, draw the horizontal asymptote, plot the point where the rational function crosses the horizontal asymptote, and also we're going to plot the points we just found in 7, 8, and 9. Okay, so this is a sketch, very rough sketch. So I'm going to use black here. So my x-axis, my y-axis. All right, x equal to 1. So let's say 1, 2. 1, 2, 3, 4, 5, 6. X equal to, let's see what my asymptotes are. Let me go back up. All right, -0.5, 0 is x-intercept. 0 comma -205 is a y-intercept. All right, 1 and -5. All right. So far. vertical asymptote at x equal to negative at 1, excuse me. One, two, three, four, five at -5. Horizontal, the x-axis is the same as your horizontal asymptote. All right, I'm gonna label that right there. When x-intercept is at -1/2, 0, so that'll be between origin, that'll be between 0 and -1. So here's 1 point. Y-intercept was barely below the x-axis, I mean, or the origin. What's that? Barely -0, -2/5. That would just be right here. Okay. All right. So what else? Let's go look up our points. Two, -2, right? 2, -2. That was the right. That was to the right of the rightmost vertical asymptote. 2, -2. To the right 2, down 2. So that'll be right here. -6, -22/19. -6, -22/19. -6. So that's just a little bit below -1, something about right here. The other point, -2, 1, 2, 6/5, just barely right above 1. All right, -2, barely above 1. All right. So far, these are my points. Okay. Now, by looking at what I have sketched so far, now let's take a look at these scenarios. Number 12. Consider the following 4 scenarios and look back at the graph we sketched so far. Okay. Which scenario is the best choice for the left side of the leftmost vertical asymptote? So right here, leftmost. So remember, graph cannot touch your graph cannot touch or cross the vertical asymptote. So if I choose this scenario, that will actually run straight into the vertical asymptote. If I pick number 3, that will also run into it. If I pick number 4, see, here's the funny thing about number 4. To pick number 4, that means you will have to come this way, cross over the x-axis, connect this point, and keep on going. Why that cannot be a choice? I know 2 and 3 cannot be a choice because that runs straight into the vertical asymptote. Why number 4 cannot be a choice for me?
The horizontal asymptote.
That's exactly right. Horizontal asymptote, because the function only cross over the horizontal asymptote or the x-axis at that point right here, the -1/2, 0. There's nowhere else. That's the reason why I cannot pick that one. So I'm using logic. That's why these extra points are for. I'm using those kind of logic to help me to decide, help me understand what I should be looking at. So that means this got to be your choice. Let me go back one more. There you go. Number 2 got to be your choice. That's the only one that makes sense. Because then I can draw this way. I can come in down from the bottom, right? Go this direction. Connect this point and keep on staying what? Below it. Number 13. What should be the best choice for the right side of the rightmost vertical asymptote? Right? The rightmost vertical asymptote. So this will be this side right here. Number 1 cannot be your choice because then that will actually, again, cross over the horizontal asymptote again. Number 2 cannot be your choice because that run into the vertical asymptote. Number 4 cannot be your choice because that run into vertical asymptote. So the only possible one got to be number 3 because you can draw number 3 coming down this way and then go over here and then hover right below. There you go. Okay. Now, the trickiest one is the one in the middle. So for number 13, we choose number 3. Number 14. Okay, I'm gonna draw, you see the picture here. All right. So 5, 6, 7, 8. I'm gonna scroll back up. Look at where the point's located, right? Would you pick this one, the U up and down, or the one go down? Well, this cannot be it because it doesn't even match how these points are looking. You know what I'm saying? You'll be like coming down, go that point, go, and then connecting. This one cannot be it. And here's the reason. If I draw a big old U, the big old U will allow me to, I can actually cross over the x-axis right here, right? But then the other side of this U looking thing will make me go back up. So if I had to go back up, then I gotta cross over the horizontal asymptote again, the second time. Same thing with the U open down. It will actually force me to actually cross over the horizontal asymptote twice, but I can only cross it at one point. So that's why this got to be your choice. That's the only possible one. So because you can come down this way, connect, 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 and then go down this way. Okay. So if you don't believe me, graph the original function. Graph the original function. Then the picture will look similar to what you sketched. So always confirm. Okay. Remember now on the homework, you will be asked to do all these little things, right? But then at the very end, you can actually confirm with your, graphing the graphing calculator, you can confirm your pictures. Okay, so there's no reason why everybody should drew these picture incorrectly, unless you just found the wrong points. So the one that we picked at the end was number 5, and number 15. From the answer that we got in 12, 13, and 14, we actually completed the graph already back in 11. Okay. That's how you actually graph the rational function. All right, so that was a rough sketch. Let's try another one. I'm gonna do the same thing, okay? All right, solve for x to find the x-intercept. And when you do this, we can already start establishing a few things. You know what I'm saying? What you can do on the homework is you can go ahead and draw yourself an x and y axis for 11. So whenever you find these x-intercept, you can go ahead and plot them as you go. Okay, but I'm gonna write it down. Here on the side, I'm gonna write these points down so I don't have to keep on going up and down. So x-intercept, find x when y equal to 0. So I replace f of x with a 0. I'm gonna use cross product again. 1 times those 3 terms on top, there will still be those 3 terms. 0 times these three terms down here will be 0. So right now, after I perform cross product, I got myself a quadratic equation. So I'm gonna factor it. For that 6, I'm gonna use 2 and 3. All right, to end up with a -1 in the middle, I got to use -3 and +2. Since the last term is negative, I know the signs in the parentheses will be 1 positive, 1 negative. All right, set each factor equal to 0. Oh, solve for x. So x equal to -2, the other x equal to +3. So my x-intercept will be -2, 0, and 3, 0. All right, let's find the y-intercept. If I plug in 0 for all the x's, you see all these terms, they're all gonna become 0. So I end up with -6 over -2, which is +3. So my y-intercept, 0, 3. Okay, you remember earlier, this x squared minus 6, right? Minus x minus 6 is the numerator. So I kind of already factored the numerator already. All right, let's factor the denominator. 4x squared. For 4x squared, I cannot use 2 and 2 because I don't think I can use 2 and 2 because then for the 2 at the end, I got to use 1 and 2. So I cannot have two 2's in the same parenthesis because that costs me a greatest common factor. So I'm going to use 1 and 4 instead. For that 2 at the end, I'm going to use 1 and 2. But I'm not going to put 2 with the 4. I'll put 2 with the 1x, 1 with the 4x. So I'm not going to have any extra greatest common factor that I don't have. So now my outer is 1, my inner is 8. 1 and 8 combined will give me a 7. All right, to end up with a +7, I need +8 in the inner, -1 on the outer. All right, reduce the common factor between them if there's any. So I can actually reduce the x plus 2. So whatever I'm reduced just now, that is a whole in my function. So now my function is now ending up with x minus 3 over 4x minus 1. All right, so let's go. So this thing, x plus 2 equal to 0, right? X plus 2 I canceled out, set equal to 0, solve for x. So that means I have a whole in my function at x equal to -2. So I gotta be careful with that. I gotta make sure I establish, when I graph it, I need to make sure I have a whole at x equal to -2. But hang on a second now. That is kind of weird. Isn't x equal to -2 is also my x-intercept? Hold on a minute now. How can I have an x-intercept here and then turn around, I have a whole at x equal to -2? What's going on here? Kind of bizarre. Because this is a restriction on the domain. So I know my function can never equal to x equal, can never equal to -2. My x can never equal to -2. So this x-intercept is actually not an x-intercept. That's actually a whole in my function. So I only have one x-intercept that I can plot. Okay, when you run into that, you got to be aware. Okay, I found x-intercept first, and then my hole is the same spot as where the x-intercept was. So that means there's a hole at that x equal to -2. All right, so the remaining 0 equal to remaining denominator equal to 0, and let's find our vertical asymptote. If I move the -1 over, that become +1. Divide both sides by 4, x equal to 1/4. So my vertical asymptote is x equal to 1/4. All right, looking back at original function. Identify the horizontal asymptote. So as you can see, the degree of the numerator is 2. Degree of the denominator is also 2. So when the degree are the same, the leading coefficient must be the horizontal asymptote. All right, so what's in front of the x squared is a 1. So my horizontal asymptote got to be y equal to 1/4. All right, 1/4. Okay, now gotta be very careful now. Okay, I only have one vertical asymptote, which is at x equal to 1/4 earlier. So pick an x value to the left of vertical asymptote. So to the left of vertical asymptote, other than the x-intercept. I mean, don't pick x equal to -2 because we already know that's a whole. So how about we pick x equal to -1? How about that? It doesn't have to be big or fancy. You're just trying to see 7, 8, and 9 is about the signs. It's about the signs of the y value because that will help you make choices later on. So f of -1 equal to -1 squared minus -1 minus 6 over, let's substitute -1. All right, -1 squared is +1. -1 times -1 is +1 minus 6. So that's 2 minus 6, which is -4 over. -1 squared is +1. +1 times 4 is 4. 7 times -1 is -7 minus 2. So this is going to be -9. Is that right? 4 minus, oh, no, not -9. 4 minus 7, -3. That's -5. So -4 over -5 is +4 over 5. So -1, +4 over 5. All right, it's positive. Number 8, pick an x value in between the vertical asymptote other than the x-intercept. So I don't have two x-intercept. Okay, I only have one. So how about we pick a number? Remember, how about we pick a number? Well, I kind of already did. I want to pick a number between the whole and the vertical asymptote. I already picked -1, so I don't really have to do this one here, okay? Because I only got one vertical asymptote, so I don't have to do number 8. All right, number 9, pick an x value to the right of the vertical asymptote. So how about we pick +1 instead? Give myself a little space right here. Oops. I'm gonna pick x to be +1. Let's see what happens. All right, 1 squared is 1 minus 6. So that's negative 6 over. 1 squared is 1. 1 times 4 is 4. Plus 7 minus 2. That's actually what? 9. Positive 9. Positive 6 over 9. Which is, if I reduce it, it's about 2/3. So when x equal to 1, y is negative 2/3. Okay. All right. Demonstrate mathematically whether the function will cross horizontal asymptote or not. Move over too much. So I'm going to set my entire function equal to my horizontal asymptote, which is 1/4. Remember that was 1/4 from the beginning. All right, let's use a cross product. 1 times these 3 terms down here, still 4x squared, positive 7x minus 2. If I take a 4 times those 3 terms on top, that'll be 4x squared minus 4x minus 24. You see this 4x squared on the left side of the equal sign, this one on the right. Same exact 2 terms, they automatically canceled out. Because if you move one of them over, it will actually cancel out. So I end up with a linear equation. 7x minus 2 equal to negative 4x minus 4. And I think 7x is bigger, so I'm going to move my negative 4x over. That become positive 4x. All right, negative 24 still on the right-hand side. Move the negative 2 over, become positive. So this is 11x equal to negative 22. X equal to negative 2. Huh. That's funny. You cross over the function at the whole? No, it can't be, right? Kind of weird. Remember now, there's a hole at x equals negative 2. So I actually cannot cross over at the hole. So that cannot be my answer. All right, so it shouldn't cross. All right, so before we make our choices, I'm gonna go ahead and draw out what I got. So here is my x axis. Here's my y axis. All right. 3, 0, 1, 2, 3, 1, 2, 3, 4. Give me a couple extra ones. 1, 2, 1, 2. Okay, sketch it for me on the homework too, please. So let's see what we got so far. All right, vertical asymptote at 1/4. Let me make this a little bigger. At 1/4, there's a vertical asymptote. Okay, that's x equal to 1/4. At x equal to negative 2, there's a hole right here. Horizontal asymptote, y equal to 1/4. So that'll be right here. All right. Remember now, hole is right there. When x equal to, let's see, when x equal to negative 1, when x equal to negative 1, the y value was 4 over 5. Four over 5. That's 0.8. All right, so that's about right here. Based on based on where I drew my horizontal asymptote, it's about right here. When x equal to -1, 4/5. When x equal to 1, -2/3. So that's about right here. All right, 3, 0 is an x-intercept. 0, 3, 1, 2, 3. Okay. -6, 1, 2, 3, 4, 5, 6. Did I pick -6 earlier? Make sure I didn't write it down wrong. Oh, no, never mind. That was the wrong one. 1, never mind. I picked -1 and 1. Okay. About to say. All right. So this is all the points I have found so far. Not much. Okay. Not much. This is a little bit strange looking. All right. So consider the following 4 scenarios, right? The left side of the leftmost vertical asymptote. I only got one vertical asymptote. I know 1 cannot be it because that will run straight into it. I know 3 cannot be it. So now the question is, okay, 2 over 4. 2 over 4. You see, earlier I did not pick a number. See, now by looking at it, I did not pick a number. I picked, let's see, what did we pick earlier? I picked x equal to -1, right? 4/5. But I did not pick another number even further away. I didn't really pick like right here. I did not pick a number in between because I kind of already did between the hole and the vertical asymptote. But maybe I should have picked a number. Maybe I should have picked a number that is actually to the left side of the hole. Because right now, I'm not quite sure what to choose here. Without graphing in the graphing calculator, I don't really know what to choose. So if I pick, because I'm really wondering, okay, what is if I pick maybe like -4, if I pick -4 for x, which is to the left side of the hole, if I pick -4, what would the sign say? What would the y value be? Would it be positive, which means I'm still above the x-axis, or am I below the x-axis? Okay. So problem like this, okay, when you get stuck, you can like, okay, this is kind of weird right here, that hole. All right, so let's come back. Number 13. The right side of the rightmost. The right side of the rightmost vertical asymptote. So that's kind of easy to pick. The rightmost, you can kind of look at this, you can tell, okay, it cannot be number 1 because number 1 doesn't really quite connect with the point I already drew to the right side of x equal to 1/4. Number 2 will run into vertical asymptote. Number 4 will run into vertical asymptote. So the obvious choice for number 13, it gotta be number 3. All right. So once I cross over x-axis, I will actually hover right below, okay, your horizontal asymptote 1/4 because it never crossed it. All right. There's no number 14 because there's nothing in between them. Okay, there's nothing in between. So number 14 here will just be complete your graph. So right now I'm stuck on 12. Left side of the vertical asymptote. So if you're not sure, just graph it. X squared minus x minus 6. 4x squared plus 7x minus 2. Okay. I'm gonna go back to standard window and you can see it. All right, remember my asymptote are very, very tight. So tell you what, I'm gonna go to the window. Remember my all my points was around, very close to origin. So for my y-axis, I'm gonna do from -5 to 5. For my y max, y minimum, -5 to 5. I'm gonna squeeze this a little bit. So by looking at the picture, I was supposed to pick number 4 for number 12. Okay, let's be very careful here. The horizontal asymptote is 1/4, right? So when x equal to -2, there's an error. Okay, but what was confusing here is this. Let me show you where it's confusing at. The hole is located at x equal to -2. But let me answer this. What's the y value? When x equal to -2, there's a hole, right? We knew that earlier because the x-intercept we found was at -2, 0. So when x equal to -2, right? There's a hole there. The hole is actually located at the x is actually located at the x-axis. So remember, I set it equal to 0. So that means a hole is located at x equal to -2 when y is equal to 0. There's a hole there. But if you think about it, when we actually solved, when we try to determine whether you will cross or don't cross, number 10, I jumped it. I was hoping somebody would catch me. I jumped it. I said, oh man, x equal to -2. It can't be x equal to -2. But this -2 is not the same y value. Earlier, the hole is actually occurred at a -2 comma 0. But this y value, we say that we set the function equal to horizontal asymptote. Horizontal asymptote is y equal to 1/4. So it actually does cross at -2 1/4. That's where the confusion was from. Because I keep on saying, it doesn't cross. It doesn't cross. It doesn't cross at -2 0, but it does. The function actually cross the horizontal asymptote at -2 comma 1/4. So maybe I need to write the y value too. So -2 1/4 right here is actually a point. So that's why number 2 makes sense. Excuse me. That's why this graph makes sense. Okay. It's coming right next to the vertical asymptote, right? Cross over the y-intercept. Didn't draw very good. It's really hard to draw. Oops, where is it? And then once it crossed it, it actually crossed it. Once it crossed it, it actually slowly, if I keep on going more negative, okay, what happened to the y value? keep on getting smaller and smaller and smaller. So once it crosses over the horizontal asymptote, it's actually hover right above the x-axis. There you go. That's what the picture is. All right. So make sure you're aware, okay, the point where it crosses at, okay? So right, doesn't hurt to write down the y value like I just showed you. All right, so 13, we say 13 was number 3, I believe. Yep. All right, so on the homework, do the same thing for me, okay? Be aware where the hole is, okay? Be aware where the hole is. So follow exactly the same steps as we just did. If you're not quite sure what scenario to pick, okay, make sure you graph your function, okay? But for number 11, draw out all your all your asymptotes, okay? Plot all your points that you're being asked to find. Then you can see, okay, the picture is kind of reveal itself. What should I be choosing? And these are multiple choice, okay? So circle your choices. Make sure you circle your choices for me. Easier for me to find your answers. All right. So just real quick, showing you a couple example on how to find or how to draw rational function by hand by finding the asymptotes, the intercepts, okay? Couple other supporting points, okay, to help, to help us make, decisions on which of these pieces of parts of the graph should look like. All right. Thank you for watching. All right, any questions or concerns so far?